Today we're going to talk about word problems with our two-step inequalities. So now we're going to relate already knowing how to solve these two-step inequalities, and now we're going to put them in the real world. So when given a word problem, it can be helpful to write an equation or inequality. It can be helpful to write an equation or inequality in order to guide your process when solving the problem. So we're going to look which word problem below is describing an equation and which is describing an inequality. We're going to circle or highlight any words or phrases that might help determine the difference between the problems. So John has a vacation savings goal of at least $1,500. He has already saved $350. He will mow lawns for $25 each. How many lawns will he need to mow to reach his savings goal? And then our other one. John has a $350 in his savings account. After saving $50 each week, he has $650 in his account. How many weeks of saving $50 did it take for John to save this amount? Well, if we notice, we have two different kinds of problems here. This first one gives a goal that he's trying to save for. It says at least 1,500, and then we want to figure out how many lawns he needs to mow after that. Over here on this one, it's saying, okay, he has this much money. This is how much he makes per week, or how much he's saving per week. We want to figure out how many weeks it was. So this one has an exact answer. So this one over here had the at least. So that means if he saved $1,600, that would have been fine. 17, 2,000, 3,000, it all would have been fine. There's several answers that could be with that one. And so this one is the inequality. You can think about whenever we graph on our number lines, whenever we shade a direction, we're saying any of those numbers would satisfy the inequality. Versus this one over here on the right, we're trying to figure out one exact number, so that means it's an equation, because we would get something like x equals 20, or whatever it ends up being. So some of our common inequality phrases, at least or no less than, is talking about our greater than or equal to. Or greater than or equal to. Think about this example right here. If he saved $1,500, that would work. If he saved $1,600, that would work because it says at least. $1,700, so he needs to save more than that $1,500 or equal to it. Now the next one, at most, no more than, well, that means we would have a less than or equal to. And then our less than would simply be our less than but not including, not the equal to. And then our more than is our greater than, not including, so it is not equal to. All right, so let's do our first example. This is going to be really similar to how we solved our word problems with two-step equations. It's going to have the same steps. So we're going to be working on this first problem that we just read about up top. So step number one, we are going to define the variable. We are going to define the variable. So in other words, what is the missing value that we're trying to solve for? Well, our question here is, how many lawns will he need to mow to reach his savings goal? So we're figuring out how many lawns he needs to mow. It doesn't give us a variable, so I'm just going to say, let's use the variable m. And you can choose any variable as long as you define it. Step number two, we identify the total. We identify the total. So if we look in our word problem, it says he has a savings goal of at least $1,500. That's our total. So we are going to put this on one side of our inequality. So we're going to put it there in the total box. Now step number three, we decide how the other values relate to our variable, as well as identifying the inequality symbol. So we figure out how everything relates and the inequality symbol. So let's look for some other important information. So it says he's already saved $350, and it says he will mow lawns for $25 each lawn. Well, let's think about it. If he mowed one lawn, that means he would make $25. If he mowed two lawns, it means he would make $50. If he mowed three lawns, $75. 4 lawns would be $100. If we have repeated addition, that's multiplication. So that means we need to multiply 25, because that's how much it was for each lawn, and then times the number of lawns, which is represented by M. So we have 25M. And then he has saved $350. Well, that only happens once. And does it cause our total to go up or down that he saved? It causes it to go up. So that means we're going to add 350. Now we need to figure out our inequality symbol. So our key phrase here is that it says at least. So you can think about back up here, at least means it's our greater than or equal to. You can also imagine, think about all of this over here on the left in blue is what he has saved. So if we're thinking he has to have at least $1,500, well, if he had $1,500, that would work. If he had $1,550 and $1,600, those are all greater than or equal to the $1,500. Now we just solve. So we have 25M plus 350 is greater than or equal to 1,500. So I just rewrote it so it's easier for me to show my work. Step number 4 is we solve the resulting inequality using inverse operations, just like we do previously. So that means, first step, we are isolating 25M. So we're going to subtract 350 on both sides. So we are left with 25M is greater than or equal to 1,150. Then since we are multiplying 25 and M, the inverse would be dividing. So we divide both sides by 25. Well, now we need to figure out how many times is 25 going to 1,150. So let's do some long division. Well, 25 doesn't go into 11, but it does 115, and it's 4 times, which would be 100. Then we have a remainder of 15, drop our 0. 25 goes into 150 6 times, and then we have a remainder of 0. So that means that M is greater than or equal to 46. Now thinking of the context of the problem, M is representing the number of lawns he needs to mow to reach a savings goal. So that means he will need to mow at least 46 lawns in order to reach it. So he could mow 47, he could mow 48, anything 46 or more. All right, let's go on to the next one. Example 2. Will is attempting to decrease the number of calories he eats every day. His goal is to eat no more than 1,800 calories a day. He always eats 270 calorie smoothie for breakfast plus 3 other meals. What is the average maximum number of calories he can eat for each of his other meals to meet his goal? So step number 1, we define the variable. So what are we trying to answer? We are trying to figure out the number of calories for each meal. It doesn't give us a variable, so we can choose. So we could use the letter C for our variable. Step number 2, we identify our total. Well, it says he can have no more than 1,800 calories a day. So that is going to be on one side of my inequality, the 1,800. Step number 3, we figure out how everything else relates. So we know that he eats a 270 calorie smoothie once in the morning, plus 3 other meals. Well, if we think about these 3 other meals, let's say one meal was 100 calories. That means after 2 meals, he would have had 200. After 3 meals, he would have had 300. And C is dependent on the number of calories. So we would have 3 times C, because he eats 3 meals. And then he also has the 270 calorie smoothie once a day. So does that cause the total calorie count to go up or down? Well, it causes it to go up. So we're going to add 270. Now we need to figure out our inequality. It says no more than. Well, no more than says that we cannot exceed 1,800 calories. So that means it all has to be less than or equal to the 1,800 calories. Step number 4, we solve. So we're going to subtract 270 on both sides. So we now have 3C is less than or equal to 1,530. And then next step, divide both sides by 3. Now we just need to do a little bit of division. So we need to figure out how many times does 3 go into 1,530. 3 goes into 15, 5 times. And we have 0, drop our 3. 3 goes into 3 one time, which is then 3 with remainder of 0. And then we have to drop down that final 0. Well, 3 does not go into 0, so that means we have to put a 0 up top in the placeholder. So we get that C is less than or equal to 510. That means Will should eat no more than 510 calories per meal. He could eat 510 exactly and be fine, or he could eat 500 per meal and he would also be fine. Anything less than, also including 510 calories. All right, number 3. On tax-free weekend, Hannah is shopping for clothes and can spend no more than $60. She finds a pair of jeans for $25 and is now deciding on how many shirts to buy at $12 each. Part A, which inequality can be used to solve for how many shirts S, Hannah, will be able to purchase without going over her budget? All right, well, let's look. We already know our variable, that's talking about S, how many shirts she can buy. We know our total is 60, so we can see on all those inequalities, they all have 60, so that doesn't help us narrow it down. And then all of them have 12 times S because it's $12 per shirt. And then she also bought a pair of jeans, which was $25, just one time. So we need to focus on our inequality symbol. It says she can spend no more than $60. And if it says no more than, she cannot spend $61. She cannot spend $60 and 1 penny. She cannot spend $70. So that means it has to be less than for the symbol. So we can automatically rule out C and D. However, thinking if she had $60, could she spend exactly $60? Yes, she could. So that means we would have the equal to. So it has to be letter B. Now step B, we're gonna figure out how many shirts will Hannah be able to purchase for $12 each without going over her budget, and we're gonna show our work. So I'm gonna copy down this problem. So our first step, we are isolating 12S, so we have to subtract 25 on both sides using that inverse operation. So we have 12S is less than or equal to 35. Next step, we divide both sides by 12. S is less than or equal to 35 over 12. Now, if we're thinking about that, is that very meaningful when we're talking about the number of shirts to have a fraction as an answer? Not really. So let's go ahead and change it to a decimal. So let's do some long division. So 12 can go into 35 2 times. 2 times 12 is 24. So when we subtract, we have a remainder of 11, but we're not finished. So we add a decimal point and then a 0, drop it down. 12 goes into 110 9 times, which would be 108. Subtract, remainder of 2, add another 0, drop it down. 2 goes into 20 one time, 12, then we have 8, and it keeps going. Well, let's think about it. Can we have 2.91, however it continues, of a shirt? No, we can only buy a whole shirt. If we were to round up, does she have enough money to buy 3 shirts? No, because she only had $60. So that means she can only buy 2 shirts. So then if we go into part C, which statement describes Hannah's possible purchasing options? Part A, Hannah will be able to purchase only 1 shirt without going over budget. Well, not technically, because we just proved right here she could buy 2 shirts. So that one doesn't work. Hannah will be able to purchase either 1 or 2 shirts without going over budget. That would work. Hannah will be able to purchase 1, 2, or 3 shirts without going over budget. Nope, because she does not have enough money for 3. And then letter D, for the same reason, if she doesn't have enough money for 3, she does not have enough money for 4. So letter B would be